Now we're going to look at some groups on the whatever aromatic structure you have. So in many cases it's going to be benzene, but let's look at some directing groups. So we have ortho, para, or meta directors. Now, before we get into what goes in which category in this table that I've drawn out, let's first talk about what ortho, para, meta means. So I'm going to draw 3 benzene rings up here. Okay, so underneath the first one, I'm going to put ortho. Underneath the second one, I'll put para. And meta under the third. So what this means is just kind of where your substituents end up. Now, ortho, you're going to have 2 groups that end up on the carbons right next to each other on your benzene. Now, the way I remembered this was thinking ortho is similar to the word orthodontist, so I'm going for dentistry. So I think the orthodontist is right next door to the dentist. So we have 2 groups that are right next door to each other. Now, para, you have groups on carbons that are 180 degrees opposite each other. So there's really nothing that I have good to remember that one, but for meta, you have a group, then we leave a carbon empty, and then you have another group. Now this one is kind of easy to remember also because if we look at this here, it kind of makes an M. So we go up, down, and it makes an M for meta. So if you can remember, orthodontist is right next door to the dentist, meta makes the M, well, para is just the one that's left over. So now let's add in some directing groups to this table. So first we'll start with electron withdrawing groups. These are meta directors, and they are these groups: NO2, if we have a carbon with a double bond O bonded to our benzene, a lot of times, actually I think in every case when you have a double bond O bonded to your benzene, this is going to be a withdrawer, so we can add in another carbon, double bond O, OH, carboxylic acid group. If you have an aldehyde on your benzene, C double bond O with an OR. So as you can see, the pattern goes, if your carbonyl is bonded to the benzene, that will be an electron withdrawing effect, and you get a meta director for your reaction. Okay, some more groups. If you have a C triple bond N, NR3, and this is where R equals an alkyl group or an H. So these are your electron withdrawers, meta directors. So an example with how you would use these is, say you had a benzene, and we had an NO2 group. So when you do your EAS reaction, you know that the group that you add using EAS is going to add to either this carbon or this carbon, because those are the meta positions. Okay, now let's look at the electron donors. So these are ortho-para directors, and then we have two subgroups. So strong ortho-para directors or weak ortho-para directors. I'm going to start with the weak ortho-para directors. These are the halogens. So fluorine, chlorine, bromine, and finally iodine. Now we also have strong ortho-para directors, and these are the following groups: NH2, an OR group, just a plain simple R. In this case, R must be an alkyl. You could have another benzene. You could have NH bonded to the carbonyl with an R group. And finally, an OH. So how would you use these? Well, say we had an EAS mechanism. And if we put one of these groups on, let's say here, and let's just go with F. So if we saw that group on our benzene, we'd know that this is a weak ortho-para director. So where could you get the group that you add via EAS? Well, it could go in the ortho spot or para. So hopefully this chart will help you. This would be very useful to be memorized because you will have to know on the exam where your groups are added when you do an EAS mechanism.